We're back with finding normal proportions. Now in the last segment we learned about the probability, finding the proportions or probabilities or area under the curve. We were looking at z less than a certain z value. We'll do one quick example today and then we're going to go further to finding areas to the right of a particular number and areas in between. So very quickly we're going to find the probability that z is less than negative 1.23. And as we said in the last slides, we said that that is exactly how our table A gives us the probabilities for the standard normal distribution. And z was that variable that represents a variable that has the standard normal distribution, that is the mean of 0, standard deviation of 1. So for the probability that z is less than negative 1.23, we look down that z column and we look for negative 1.2, and then across the top of the z for the hundredths place, 3, and we find where those two intersect, and they intersect at 0.1093. So that's that probability that we were looking for. Now we're going to see how we find areas to the right of a particular z value. So this is what we're going to do here. We're going to find these probabilities. So this is what we're talking about. We're trying to find the probability that z is greater than 1.68, but the chart doesn't give us things greater than, it only gives us the less than. So we can only find not the darkened area, but the area that's not darkened. But that kind of gives us the clue as to what to do. That means that we're going to need to use the complement rule here. We want to take everything underneath the probability, subtract off that white area, and get the dark area. So let's see what we mean by that. So we want to take the whole area, this area right here, so the area under that graph is 1, and we want to subtract off, as I said, everything less than 1.68. So basically what that means is subtract off that area. That means take all of this, that area there, and we're going to subtract it off. And so what will we be left with after we take that area off? The area that we wanted. So that basically looks like this. So there we have it. We have the whole distribution, the darkened distribution, all of it, that would have probability of 1, minus everything to the left of 1.68. So if I subtract off that much probability or proportion or area, I'll be left with the upper right of the distribution, and that's exactly what we wanted. Now I've got a way to find that probability using the chart, because I know what 1 minus, and I can find the probability that z is less than 1.68 from my chart. So let's take a look. From the empirical rule, remember within one standard deviation from the mean, we knew 68% of the data lie. Then we took that and we said, well, due to symmetry, now I would know what probability or proportion of data lie between the mean and one standard deviation. We said 34. So the dotted area to the right of the mean equals the dotted area to the left. We agreed that that was true. Well, that would also mean that due to symmetry, that the area to the right of a certain value has to equal the area to the left of the negative of that value due to the symmetry of the distribution, which we see in the plot right below, or right next to the dotted one. So we're going to use that to help us solve for the probability that z is greater than 1.68. So by looking at this, just by what I just wrote down, the probability that z, or the proportion of z less than a negative z value, has to equal the proportion of a z greater than a z value. Can you see how you can use symmetry to help you find the probability that z is greater than 1.68? Well, let's just put that into our equation. So by putting the numbers in there, now to find the probability that z is greater than 1.68, all I need to do is go to the chart and look at the probability or the proportion of values that z is less than negative 1.68, and we're ready to go. So let's do that. If I look on this chart, I look up negative 1.68, and when you do that, we get exactly the same answer that we got when we did this using the complement way. We get 0.0465. Pretty neat. And we're done. So that's just another way you can find a probability of z greater than 1.68 or z greater than any z value. Now we're going to look at areas in between. How do we calculate those? We'll look at how it can be written up and take note of the less than and less than or equal to signs. Remember, since the probability at any singular point equals 0, it doesn't matter whether we have a less than sign or less than or equal to sign. So you can have this same question asked in these different ways. So let's look at how do we find areas in between. Well, we want the area in between. That's the first graph that we see up there. We want to know the area in between negative 0.51 and 1.87. Well, the only thing that we can get, remember, from our standard normal tables are the probabilities or proportions of z's less than a certain z number. We also know that the area underneath the curve is 1, and that the mean, the area to the left or to the right of the mean, is 50% or 0.5, proportion of 0.5 or probability of 0.5. So let's see how we'd proceed. We'd first start out with getting from the chart the probability that z is less than 1.87. But that's too much area. Look, it's the whole left tail is in there. And how much is too much? How much area is too much? It's just what you see here where the arrow cuts off that graph. That's too much. It's that left tail end to the left of negative 0.05. So we're going to subtract off that proportion or that area or that probability to the left of negative 0.51, and that would give us the area that we want. So here we go to find that area in between. The probability that z is between negative 0.51 and 1.87 is equal to the probability that z is less than 1.87 minus the probability that z is less than negative 0.51. We can find those two areas in our chart. Make sure that you're following along, and you can do this too. In the chart, I look up 1.87 and I find that probability to be 0.9693, and the area to the left of negative 0.51 I also get from my table, and that's 0.3050, and I take the difference of those two. So therefore the proportion of probability, or the area in between negative 0.51 and 1.87, is 0.6643.